Hi everyone, today we're going to talk about scalars and vectors, and this is an incredibly important part of physics because we classify all of our information into one of these two categories. A scalar, S-C-A-L-A-R, is one that can be described by a single number. A scalar only has magnitude. It's degrees Fahrenheit, or your height in inches. It's your mass in kilograms. It's the distance from here to your grandma's house. It can be described by a single number. A vector, however, has both magnitude and direction. So it's something like a velocity, meaning I'm going 100 miles an hour west, or a force, I'm pushing with 10 pounds or 10 newtons down. A displacement is how far you've traveled in a certain direction. Take 10 steps east. And we often use arrows to represent vectors. The direction of the arrow gives the direction, and the length of the arrow gives the magnitude. And by the convention we use, the length of the vector arrow is proportional to the magnitude of the vector. So if the 4-pound block had a weight arrow like that, then the 8-pound block is going to point in the same direction, but the arrow will be twice as long. The length is the magnitude, the arrowhead is the direction for a vector. So imagine that you have a car that's traveling 2 kilometers. If we just said a car has traveled 2 kilometers, he could end up here, he could end up here, he could even end up down here. We'd have a circle, which our car could be anywhere on that circle. So by having a vector, it gives us an idea of where that car is. If we say our car has traveled 2 kilometers, 30 degrees north of east, we're saying this direction is east. And we almost always measure from east going counterclockwise. And in this case, do you see how counterclockwise is from east towards north? So we've gone 2 kilometers, 30 degrees north of east. That tells us exactly where that car has ended. Sometimes, however, we have to add one vector to another. So, for example, if you went for a walk and you walked 10 steps east, and then you walked another, see how this arrow is shorter? Another 4 steps. That would be the same as having walked 14 steps to the east. And that R, down here at the bottom, that R stands for resultant. And the resultant, I'm going to put it up here, is the answer in a vector addition problem. Okay? And when we add vectors, we use what we call the tail-to-head method, meaning we put the tail of one vector at the head of the last. So if I were going to add 3 of them, if I were going to add this one, and this one, and this one, the way I would add them is I'd draw the first one, and then put the tail of the second, head of the first, draw the next one, and then the next one. And my resultant always goes, let's see if I have another color, a resultant always goes from the tail of the first one to the head of the last one. So that would be my resultant, R. Okay, so let's go back to my pen. Back to blue and keep moving. Okay. So imagine, for example, that I had a 3 Newton vector that way. So imagine someone, for example, is pushing on a box, and he's pushing with a force of 3 newtons that way. But there's someone pushing against him, pushing with a force of 5 newtons that way. I would add those in a head-to-tail way. So I would add 3 newtons that way. That one's 3 newtons. And then from the tail of the first to the head, that would be my 5 newtons. And then I would start at the beginning and draw there. That one is my resultant. Do you see my resultant then would be 2 newtons to the west? Because I'm going back. Okay? So what if our vectors aren't all along the same line? What if they're not parallel to each other? Well, if they're a right angle to each other, we can actually use the Pythagorean theorem to find the length of that vector. Okay? So imagine then that vector A was 4 newtons and vector B was 3 newtons. Now often when we write vectors, we put this little arrow above the letter. That's the way to tell us they're vectors. I don't always remember those. If I don't and you want to correct me, feel free. So we'll add those together. We're going to say, okay, I have 4 newtons this way, and if vector A is east and vector B is north, I can put vector B, same way. You'll notice this is still the head-to-tail method. I put the tail of the second one at the head of the first one, and then my resultant goes from the tail of the first vector to the head of the last vector. That's my resultant. But I can't just add 3 and 4 because you know that that distance isn't 7. So to do this, I'd use the Pythagorean theorem. R is going to be equal to 4 squared plus 3 squared, square rooted. Now hopefully you recognize that that's a Pythagorean triple. And my resultant is going to be 5 newtons. But it's not 5 newtons east, and it's not 5 newtons north. It's 5 newtons at some angle north of east. So how do I find that angle? And the way I find it is with my trig functions. Okay? So remember that angle theta is going to be the inverse tangent of the opposite, B, divided by the adjacent, 4. It's going to be the inverse tan. I'm so sorry. The inverse tan of 3/4. And that actually turns out to be, I think it's 57. I think that turns out to be 33, although I don't have a calculator, so I can't check, give or take. So I would write this then 33 degrees north of east. Okay? So how do I subtract vectors? And the way I subtract vectors is I multiply a vector by -1. So if a vector is multiplied by -1, the magnitude of the vector remains the same, but the direction is reversed. So if this is vector A, then this would be vector -A. It's of the same length, but the arrow points in the opposite direction. If this were vector B, then that would be vector -B. And if this were C, that would be -C. Okay? So to subtract, we multiply by -1 and we add. So if I wanted to know, let me get rid of some of this so you can see down here. So if C, this red one, is A plus B, which you can see, head to tail, A and B, and the resultant goes from the tail of the first to the head of the last, then if I wanted to find C minus B, that would be the same as C plus -B. So I'd flip B into the opposite direction. Do you see how now B points down instead of up? And I would add C first, so we'll draw C first, and then negative B, and we'll end it up with A. Okay? There's more information on this in your book in 1.4 and 1.5, I believe, if you need more information. Okay? So we're going to stop there, and next lesson we'll talk about the components of a vector, and we'll go on from there.